Up until now, we have been given the fact that the shape is a parallelogram and drawing on those properties. Today's a little bit different because instead of knowing that it's a parallelogram, we have to prove that it is given the information that we have. So today, we are focusing on how to prove a quadrilateral is a parallelogram. But first, a little review. Go ahead, plot those points, find the slope of AB, and then find the length or the measure of AC. Alright, so on that graph, we can see between A and B, to find that slope, we are going up 4, so it's a positive 4, and to the right 3, so a positive 3. So our slope is 4/3. Now, to find the length or the measure of AC, and I circled those points up there in red, is the distance formula. So the square root of our x values, the difference of our x values squared plus the difference of our y values. Now, you can go ahead and leave it as the square root of 34. Since it doesn't simplify, I don't need you to go 5 8/10, and you're going to see why here in a little bit. Alright, so we've got two theorems here, and we've really already talked about this, but this is just the converse. So the converse says, hey, if you have opposite sides that are congruent, well, guess what? It's a parallelogram. And if you have sets of opposite angles that are congruent, guess what? It's a parallelogram. So it is literally just the opposite or the converse of what we talked about yesterday. Now, I don't know if any of you have been on, I think it's like the Starship ride. I can't remember for sure. It's blue and white at Adventureland. But the ride looks somewhat like this, where you get in on your seat and you go up side to side, across, back down, and you do that several times. Now, this question asks, explain why the moving platform AB is always parallel to the ground. Well, no matter what, doesn't matter, wherever this is at, the opposite sides are 16, these opposite sides are 38, so they're congruent. So no matter if it's way stretched out like this, they're still going to be parallel because the opposite sides are congruent. So it's that converse that we just talked about, that theorem. All right, now let's add to it a little bit of algebra. I'm going to have you pause the video here, and I want you to figure out number 2 and number 3. All right, so in number 2, first we got to solve for that fourth angle. And since it's a quadrilateral, we know it sums up to 360 degrees for the interior angles, which leaves angle Z to be a measure of 138 degrees. Well, to answer the second part, yeah, it is a parallelogram because the opposite angles are congruent. We've got 42 and 42, 138 and 138. So by the parallelogram's opposite angles converse, we do know that this, in fact, is a parallelogram. Number 3 is a little bit of algebra, nothing you aren't used to. So setting those opposite sides equal to each other, x plus 9 is equal to 2x plus 1. Doing a little solving, we get x has a value of 10. Now over there in yellow, I wrote in 10 for x because we know that these two opposite values must be the same. So y is equal to 10 plus 7, so y is 17. All right, we got two more theorems how to prove a parallelogram or a quadrilateral is a parallelogram. So this top one is a little bit unique. We haven't had anything like it yet, but now it's saying all we need is one pair, just one, not two, just one pair of opposite sides. So in this case, BC and AD, they are congruent and parallel. So they're both congruent to each other and they're both parallel because then that actually ends up forcing those other two sides to be congruent. Now, the last one is similar to what we talked about in our last lesson. It's the diagonals converse. So if the diagonals are bisected, well, guess what? It's a parallelogram. So if I have a quadrilateral where the diagonals are bisected, I know that those diagonals are the diagonals of a parallelogram. So we're actually going to apply these two theorems since they're a little bit new to us. So take a look at number 4. It says the door shown is part of a building in England. And you can see that the building has leaned over time. It's gotten a little bit tippy. Now, explain how we know SV is congruent to TU. Those are the two sides of the door, the left and the right side. But if we take a look at the top and the bottom of the door, we can see that they are parallel and congruent. Well, because they're parallel and congruent, therefore, this whole shape must be a parallelogram. Well, guess what? What do we know about parallelograms? The opposite sides are congruent. So that would make SV congruent to TU. And last one here, I'm going to have you pause and I want you to go ahead and solve this problem. Well, if it needs to be a parallelogram, that means the diagonals have to be equal. So I set them to equal to each other. 5x minus 8 is equal to 3x. Do a little bit of algebra, subtracting 5x from both sides. We get negative 8 is equal to negative 2x. Then dividing both sides by negative 2, we get x is equal to 4. But are you right? Let's check it out. Plug it back in. 5 times 4 is 20. 20 minus 8 is 12. 3 times 4 is 12. We got them equal to each other. Therefore, you know that you did your algebra correctly. We're going to go ahead and pause here for section 7.3, and then we're going to do another video to finish out the rest of the lesson.